3D. You click on 3D. This pops up. Number of stories, number of bays on x-axis, number of bays on y-axis. So stories, ours is a 2-story building. Height of each story is 325. The 310 you have, wait a second. Here in this Excel, in the project, sorry. Why is that? So that top floor, this is just a room upstairs. We neglect this so you don't exceed the 130. Here, see this section we neglected. That's one thing. And here, this height 310 is 122 plus 15" for the beam. We go to 122 plus around 15. This is just assumption so far. That is 137" height. So that we take this height for both floors. So height is 137". That's for each story. Number of bays on x-axis this way. How many bays we have? We have, you go to here, go to the beam C here, or this one, or this one. 1, 2, 3, 4 bays. Because we have a beam here, beam here, beam here. We go with the beams. So number of bays for, on the y-axis, we have 2 bays. 1 bay, 2 bay, 1, 2. Each bay, we take it as 177, including the width of, this is 40 centimeters, so that would be half this way, half this way in inch. This will be 177, 177. So please take it as 177 by 177. So on the y-axis, each bay is 177. For the x-axis, the width of each bay is different, but for now, you can put any number, let's say 228. And then we click on it, it generates a 3D model for us. It opens 2 windows. Usually I keep the right one in 3D. You click on this 3D. See, you click on the window here. When it's highlighted blue, it's active. You click on the 3D. It generates your 3D. And I come back on this window. I work on this window. I make it kind of bigger, drag it to the side. And now what I do, I select all and delete. Now I just have the wire mesh. And then I do right click, edit grid data. Here what I do, I edit these dimensions. the spacings. Now I have all of them at 222, but they are not 222 all the way. See here, dimensions change. This one, please write it down, 142 to the center, center to center, center to center. 142, 228 here. That 220 is 236. And the last one is 181. 181, 236, 228, 142. And the base, each base 177, 177 from the center of the columns. So now I change these dimensions. How I change it? I click on this window, right click, edit grid data. We modified, we have one already. You can go by ordinates or spacing. For me, spacing is easier. And pay attention to here, see A, B, C, D. A, B, C, D, E is the last line. So the first one, this one, is how much? Is 181, 181. The second one is 236. The third one is 228. The fourth one is 142. 177, 177 on this base, like from 1 to 2, from 2 to 3. Those grids are okay. And now I say, okay, okay, you'll see the shrinkage. See it shrink? Now this space is small, 142, and then 228. And then here you have 236, 181. Now I define my materials. Material. By default, we have 4,000 PSI concrete, but ours is 3,500. So ours is 3,500. And you go to here to calculate your Young's modulus. See this equation? E is equal to 57,000 times square root of 3,500. And that gives you 3,372,165. So when I put that number in, so now we add a new material. The new material is concrete. Grade is not 4,000. We can say 4,000. Let's say 3,000, and then we modify. Or we can modify this one. This one, modify. When you modify it, what you change? So the unit weight is 150. Come back to PSI, pound inch. This E change. How much is it? The number I just showed you, you need to calculate from that equation. 3,372,165. That's E. Poison's ratio is still 2. Don't change those things. See, this automatically gets updated. Here, that 4,000, we make it 3,500. I got an email how to do this. That's how you do it. And it's not lightweight concrete, it's regular concrete here. And the beauty is of this is you can change anything you want in it and change these names so you don't get confused later. And when you change the units, see, this is 115, now this is in pound foot. All of this gets updated. We go with pound inch. Okay, now we have this. The steel, we update that too because our steel is 60,000. So it's FY 60, 60, 29,000. We keep it as it is. That is 60. Keep everything 60,000. 60,000. 60,000, just to keep it simple. And this is unit weight of steel is around 490. You can check it, it's 490 poundage. Now we have changed our materials. Now we have the correct materials. We have the materials. Now we add the sections. We have beams, import new property, concrete, a rectangular beam. Not here. Not import, add new property. Concrete, rectangular beam, just name it beam. The reason we put the beam now is so we include the unit weight from the beginning, so we don't do so many revisions. For now, we just say 16-inch by 16-inch beams, just for now. Later on in your calculations, you will find this. So please hear me out. These 16 by 16s for the beams are not the exact number. This is just an approximation to include the weight of the beams. Later on, when you calculate your beams, you know the exact numbers. Maybe depth comes out to be 12-inch, width comes out to be 10-inch. So this is from your calculation. But for now, we want to include weight of the structure. So you get the rough estimates of our moment, or moment and shear and axial. That's why we do this. And here we pick our material. 3,500 psi is the concrete. And we don't put in rebars. This is just like to show you this is a concrete section. We have not put any rebars in it. This is the beam. Now we do the columns. Same thing for columns. Name it columns. Go with 16 by 16 again, just to include the numbers. Later you will find the section from your calculations. And this is the material. And now we have beam and columns. What is left is the walls and the slab. Add new. Come back here. Go to shells. Where are the shells? No. Here. Define area sections instead of frame sections. For columns and beams, we went to frame sections. Now we go to area sections for the slab and for the CMU walls. Shell, add new, call it slab. Let's put it as 7-inch. Thin shell. Let's go with 7-inch for now. Again, this 7-inch is not the real one. The 7-inch, you'll calculate it. The material 3,500 psi. And this is your slab. We can pick the color as well. Let's say the slab is red. That's the slab. And we do the wall as well. For the wall, You gotta add another material, but let me just go back to the beam, see what color I have in the beam. This color, let's have the beam in blue. The columns, let them be, we have blue, we have red. Let's have the columns purple. Now in the materials, we have concrete and steel. Now what we do, why we have add a new material. Let's say other, okay. That, call it masonry. For masonry, unit weight is 125 pound per cubic foot. So you change the unit here. So you put 125 and now change it back to pound inch. Here, put masonry has Young's modulus from 1 million to 3 million. So let's put 2 million. And this is 2 Poisson's ratio. So please be careful of the units. When you put the unit weight, change the unit to pound foot. It's 125. I know it in pound foot, pound per cubic foot. Young's modulus, I know it in pound per square inch. So I change to PSI and then I put it 2 million here. Now we have masonry too. We have 3 materials. So this is the one we did the steel. 60,000. And this one I deleted. Why doesn't let me delete? It's okay. We don't use steel. Now I come back, I add area section. I have the slab. I add another one called masonry or CMU. CMU or name it wall. This is CMU wall. Thin shell CMU wall is 8-inch thick. Here I pick masonry. In the material, pick masonry. Okay, now I have masonry, wall, and slab. Now I start my artwork. In the drawings, what I have beams 1, 2, 3, and 1 all the way. So I draw one from the middle from here all the way to the end. You click on this thing. This is for frames. Click. It says what you want to draw. I draw beams. My beams are from here to here. And be careful, zoom it in. Sometimes you click on something wrong. Here, here. And then when I want to end it, I do double click. 1, 2. One beam from here to here. See, this is too close. I zoom it in. I don't want to click on the top. I click on here. And if you want to move it, see this thing here? This rotate 3D view, you can rotate it. So you don't have lines close to each other when you draw something. Or you can do this. See YX, you can click on YX or XY and see the plane is at the top. I move it to the middle I have it here. I click on beams. Says beams now by default. Another beam here, another beam here, one here, one here, one here. That is my beams. Now I go to my columns. 3D. See the beams are there. I go to columns. I do this view. See ZX. I do ZX view or XZ. See the plane. The neck looks. Shows like this, right? So this is the beams. I have columns. Let's check. I have one column here, one here, one here, one at the very back. So I click on this, change it to columns. We have one here, one here, one here, one here, 4 columns. And now I click on 3D. It looks realistic. 1, 2, 3, 4. Now we do the slab. In order to do the slab, we do top view. Top view is YX. Y. Let's do the slab. X, Y. See, this is the middle. It shows us where's the plane. Now we click on this guy here. On this guy. The openings make everything a slab. You see, it's on slab. Slab here, slab here, slab here. Just click on the spaces, the panels. These are the slabs in the first floor. And I stop it. Now on this 3D view, click on this arrow, this option. Go to general options, do extrude. This shows you the members here in 3D. Apply. See, now it's in 3D. The slabs and the beams are all together, and you can flip it over and check everything. Everything is drawn center to center. That's how SAP draws. You see the beam going through the slab. That's okay. That's how SAP draws it. Now I should let's do the top floor. Top floor. See, I bring the panel to the top. Now it is at the top. On the top floor, the same thing, slab everywhere. 1, 2, 3, 4, 5, 6, 7, 8. Now we have the slab as well for the top floor. If you want to see it here, you just need to click on this and just say okay, and then it shows up. Now what is left is the walls. The walls, you come back here, go to the plan view, and wherever you need assumptions, do it. We have CMU wall all around. That's a good thing. We do the round ones. See, this is the CMU all around. CMU all around. So let's do all around first. sap. When we do all around, we do this plane view, which is XZ. I work here, X for XZ. We do this panel first. So let's see where we at. We are right in the middle. We don't do the middle yet. We do this outer panel. CMUs everywhere. Click here, just like the slab one. Pick CMU wall. 1, 2, 3, 4, 5, 6, 7, 8. And I believe we picked green for CMU wall, or did we? Let's check it here. See, it's CMU is red. We can change it here. CMU wall, modify, changing the colors. Help you pick up where you at. And here, extrude materials. Change this to materials if it doesn't show it in a different color. Did we? What happened? I thought, this will be green, so we don't mix it with the beams. The beams are a blue. Green, green. And now we go to the other side, all the way the other side. Click on this window, go to the other side. Now we do CMU wall everywhere. And now we go to the very back, which is YZ. YZ plane. We go to the very back. See, the plane is in the very back. This is the last column here. Click on here. Wall, 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 wall. And now we come back here. We're done with the exterior. We have one wall here at the basement, one wall here, one wall here. So this wall, we cannot put it in. We have a grid here. So one wall here at the last and the second column. So we come in, and this, be careful, zoom it in. Or here, click on this, move it so you can see inside, just like that. We add a wall here, the basement wall here and wall here. So this D1, this panel is this panel. So I come back here, I do a wall here, see it added here, and then I come outwards. Let me to a 3D. You gotta be so careful where you add the walls. I added one wall here in this panel and come here. Now we are here. We have one wall at the basement right here, which is this one. I add one wall here. See it added it here. Now I am done with the walls for the basement. Double check with 3D. Move it. See you see the walls. One wall here, one here. Now we go to the second floor. In the second floor, we add one wall here. That's not a. We add one wall here, one here all the way. So we add one here, one here, one here, and one at the very front. We go back to SAP and the same panel. On this panel, we don't have anything. Let's start from the back. At the very back, we did the very back. The second panel, which is this one, we add one wall here. On this, where this is, this will be the wall. So that would be here. One wall. And I may do mistakes later on when you start working on it. Please do it the correct way. And now we come and this panel here, this is the panel. That's the first one. Oh, I know what I do now. That's the very back. We did this one. Or did we? I guess we did it wrong, but it's okay. We'll go. Let's see. We said one at the first panel, one at the second, one here, and then the very front. Yeah. We will redo it. See, this is at the basement. We have one here, so we are here. We add one to the second too, which is here. And then at this panel, we have one here, one here. And in this panel, we don't have anything at the top. That's the opening, the living room area. And at the very front, that's where we did this mistake, which is not, we just add one more here to close it. Now we are done with the walls. So here, if we do final 3D view, flip it over, you see the box with the walls in it. One here. Basically, see, this is the columns, the column, one wall here, one wall here. This is at the basement. We have a bedroom here. The second floor, that's the room. That's the room. See the walls at the front, at the top. Now we go to the loads. Now we are done with the building. And here I do 3D, define the loads. Loads. You define loads here. We have a dead load, self-load multiply. Yes, we want the dead load to be self-weight included. That's by default. And then we do live load. Dead load, we have one more thing as well. And we have something else as dead load. Oh, furniture. Here that 37, 10, 10, 10, 5, 2. That is 37 pounds per per square foot. You can put it in just like that. So we need to change the units first. Pound foot. Pound foot. Now I go and define load patterns, another did. So that's my did. Now I add live. For live, I don't want self weight to be added to the live. I say add. Now I also add CMU wall. I'll just say wall. I'll tell you what those walls are. Those are the non-shear walls that did. Self weight doesn't need to be included because we include the wall weight anyways. Now we have 3 loads. Now load cases, dead, live, wall. They're all linear elastic. If you want to modify, go to inelastic, you go here. But I don't require inelastic. It's all dead, live, static. Now, from the drawings, see like those, this kind of wall, this kind of wall. This wall, this is the basement. See, in the middle, we have this wall. No, we don't in the basement. I don't think this wall is there. Don't put in this wall. In the second floor is where we add the CMU weight walls. So for the beams, we added one wall here, one here, one here, one here. Let's run it like that now, for now. Now we apply dead load and live load. So we go to Y, X. We go to the first floor. See, that's the first floor. We apply assign. Load is area load. You can do area load. You can also do, we have point load. What I'm doing. If you have point load, you do here. If you have distributed load, you do it here. If you have area load, you come here. You can do uniform shell or gravity. Ours is uniform dead load. And we need to pick up the areas. 1, 2, 3, 4, 5, 6, 7, 8. All the areas. See, it's all selected. Assign area loads, uniform shell, dead load, gravity. Be careful here. The load C Z axis is upwards, is positive. We go downwards, so you put it in negative. So our dead load is 37 pound per square foot. C is pound per square foot. So you put 37 here. Replace all existing loads. There is no existing loads, but if there is, replace it. Now we've added the loads to the first floor. Now we go to the second floor. At the second floor, dead load again. The same amount. Sometimes SAP does that. Let's go to the first floor again. Apply the live load. Assign. Fill. Live load. Our live load, we said from A says 40. This is 40. We don't have any extra live load, but just for, so, oh, do you know why it doesn't do it? Because I haven't selected the areas. Assign. Area load. Uniform. Live load. 40. Any live load, replace it. That is the live loads. Now we finished the first floor. We go to the second floor. And then click on the areas. Assign area load. Live load is still 40. And then this time we do dead load. We did live load, we do dead load. Dead 37. Now we have dead load and live load everywhere. Now what we do load combinations. Do load combinations, a new load combination. What is the load combination? 1.2 dead load plus 1.6 live load. So dead load multiplied by 1, added. Later on, you add the CMU walls. And live load, oh, sorry. The dead load, I gotta multiply by 1.2. That is the factor. Now I do live 1.6. Add. If you're modify, you select the load. Modify. If you wanna add, you say add. Now I have 1.2 dead load, 1.6 live load. That's my load combination. Now I still cannot run it because the boundary conditions at the bottom face needs to be fixed. And this column, this are fixed and assigned, joined, restrained, apply fixed end. That's where the foundations are. And these make them, these should be spring basically, but since this is a student version, we just go with pen. apply pin to those locations. Now I guess we can run it. When you run it, before you run it on your computer, on your screen, just add a new folder, whatever you name it, project sap2000. Now we run this. You click on this thing, it says run. When it says run, it locks it, you cannot be changed. Run those loads, run. Desktop, we said project sap2000, CEE410, save. It takes a few seconds to run because we have so many members in it. And if this goes beyond 150, let me know, we can fix it. So now here I say I want my moment diagrams for the beams from the load combination. If you're on axial force, click on axial force. If you're on moment, you click on moment. See, that's the beauty of SAP. That's all you need from SAP, your moment diagram. Let's say this beam in the middle, see it's that beam in the first floor. Right, hover on it, right click on it. When you right click on it, this pops up. And be careful of the unit. See, the unit is pound foot. You can change it to kips foot too, so whatever you want. And this is the moments. Click on maximum. See 10 kips foot is your maximum moment on this. If you want to know how much is moment at any location, you can change this. And see this, check both moments. But this is your maximum, 10 kips foot. So you design this beam for 10 kips foot, and that would be it. And if you want to know shear force, and that is your shear here, 3.172 kips foot for shear. And if you want this beam, click on the beam, right click, kips foot. See 8.5 is maximum, which seems too low for me. Maybe I've done a mistake somewhere. And this is my shear. And if you want to know from dead load only how much you get, you can check. See, dead load gives the most. 6. Live load gives 2. Both gives 8.5. And if you want to check the columns, for example, this column, click on it and then right click. This is your column. It doesn't have, it has too much moment on it. No, this is pound. This is the moment, 0.2. And the axial on it is 6 kips. This is the axial, which is not much. And for the slab, you can do this. Click on this one, or even this one. Come here, go to shells. You want the load combination. Show me maximum moment. If you want to add arrows, you can add. In your log max, it doesn't work. When you do dynamic, this goes to steps. Can say show the deformed shapes. This is your sap, your slab here. But if we do it on this, it will be much nicer. Uh-oh. So here in this slab, let's do this shells, 2.6 max, moment max, that's what you want. And I don't know why it doesn't show it. I want I want to show to in as the stresses. You can tell where is maximum stress this way. Yeah, see, it tells where is maximum stress. Blue all the way to purple. So we are somewhere in the between. This section is under maximum stress. That's where you'll find your maximum moment. Come back here. Moment. And you can hover on each one. See, it gives you moment in pound foot. If you want in kips foot, it's almost nothing. 0.03. The top floor, the bottom floor. We need to rotate it. So 0.02 kips foot. 0.02, 0.02. It looks like 0.02 kips foot is maximum bending moment you got. And I'm telling you, this is not accurate. Why? Because for this slab, you need to divide it into smaller grids to get accurate results. For the walls, the same. For the beams, the same. But since we are restricted by the number of the rebar of the structural members, it cannot be more than 150. We got to go with the big plates, because SAP is based on lump mass, and for lump mass, it's a structure dynamic topic. The smaller members you go, the more accurate you are. This is analyzed based on matrix, and the more smaller units you have, the better it is. For example, this, if I unlock it, so this section, for example, is, we go to edit, and I guess it is it. was somewhere. It's somewhere. It's 1 year I've not used SAP. I've started forgetting things about it. Yeah, divide areas. So that you want to divide it by to how many? By how many? Let's say 10 by 10. It divides it into smaller segments. And you do that for everything, for all the slabs and the walls. But you cannot do that because yours is student version. If you do this, you go out of the 150 capacity. This gives you more accurate answer. But it's okay. All we want is just to get some numbers here. And I highly advise you to start calculations with some fake moment results, shear results, axial load results for the beams and the columns. So you can type it, and at the end, when you get more familiar with SAP, you get more accurate numbers. When you go back, you change your moment, and all you do is you just change the numbers. You don't kill time with typing and checking your project. And I hope this gives you something to at least play with it. I know it is a lot, but at the same time, I know you guys are engineers. You can handle it. Tanner, I like this cartoon kind of shape. Yeah, you guys can go unmute, and if you have comments or questions, let me know.
I was just wondering how long do you expect us to take to learn SAB and to like complete this project for the SAB 2000 part?
Believe it or not, I've never taken any classes on SAP. I did some YouTube search, and a friend of mine a couple of times gave me a couple of like sessions, just like what I did now, and then I learned it. It's just like AutoCAD. The more you play with it, the more you learn. But in 1 week, you should master it. It's not much. And we do linear, we don't do non-linear, and we don't input the rebars and the stuff. There's other ways. When you do the beam cross section, you can add the rebars, the stirrups, all the stuff, and gives you moment curvature plots, those kind of stuff, but you don't need it here. I just want you to be familiar with SAP 2000. So you add it to your resume saying, I know about SAP. That's a big thing in the markets. So basically from SAP, what you get is for the beams, the longitudinal beam, B1, pick maximum moment somewhere, design your beam for that M1 and apply it to all the beams on the long run. For the short beams, the parallel ones, find maximum moment and apply it to all the short beams, the 6 beams. And again, for the long run, find maximum shear from SAP, apply it everywhere for stirrups. Find maximum shear on SAP, apply it on the 6 short beams everywhere. So you need 2 moments, 2 shear from the SAP for the beams, and moment and the axial load on one column that carries the most, and apply it to all the columns. And 1 maximum moment anywhere in the slabs, the 2 floor slabs. Just pick 1 point that gives you maximum moment. Like tonight, it gave us 0.02 Kipp's foot, but that looks so low. And then apply to the slab everywhere. So basically, from the slab, you just get moment and shear and axial load, and that's it. You don't design on the slab. We just analyze it. Okay. And on Tuesday, November 7, we don't have class. We will meet on Thursday. Don't forget to bring back your midterm corrections. Staple it to the old one. And we will finish columns in the next 2 sessions. And then we may come back, do SAP work in class. Maybe, I'm not saying we will, maybe. I don't want you to wait until the very end. I want you to start working on the SAP. Any questions? Okay, have a good evening, everyone.
Thank you.
Bye-bye.